Okay, just a few other really quickly mathematical things that we got to do in physics, and this is huge. This is so huge. Manipulating formulas is going to be huge for you. Okay, so don't worry, we're going to have a lot more practice at this, but I'm just going to do a few for you here. So you're expected to be able to do 2 or 3 step manipulations. So, first one. For example, we have F equals ma, and it says solve for A. A is acceleration here. So again, if you were in my class, I always say do the opposite what's being done to A. So here ma means m times A, right? So right now A is being multiplied by m, so I need to do the opposite. I need to divide by m. But anything I do to one side of the equal sign, I gotta do the other. Perfect. So those m's cancel out. And what do I get? I get F over m on the left side is equal to, A is all that's left. There we go. Perfect. So acceleration will equal force divided by mass. Okay. If you have gotten here in math at this point, you've seen this equation y equals mx plus b. So hopefully it does look familiar to you, and if you guys haven't gotten to it yet, then okay. Now we're going to solve for x. So 2 things are being done to x. Right now it's being multiplied by m, and it's b is being added to it. So this is the opposite of bed mass. You always have to kind of go backwards. So actually I want to get rid of this b first. So I'm going to do that by subtracting b on that side because that's the opposite of adding. Then I subtract b on that side. Okay. And so that gets rid of that guy, and we have y minus b. Okay. So we got y minus b is equal to, and then we still have mx there. Okay, so this is not done because, well, x is still not perfectly alone, but remember, x is being multiplied by m. Opposite of that is dividing by m. Now make sure you divide this whole thing by m. That's going to be really important. Okay, perfect. Now it cancels out. And now finally we can get to our final answer where we get y minus b all over m is equal to x. Yay, there we go. We did it. Okay, this one is so important. V equals d over t. This is one you're going to be using a ton this week. Like, we're going to do this right after we're done all this stuff. So V equals d over t is huge. So here we're going to solve for t, but you should be willing to solve for any of this stuff. Now, I know I've said it to the people in my class. T or anything that's in the denominator cannot be solved for. It cannot be isolated if it's in the denominator. So first step, get it the heck out of that denominator, okay? How do I do that? Well, if I multiply this side by t, yeah, those cancel out. But anything I do to one side, I got to do the other. So I'm going to multiply that side by t. So then I get a slightly different equation. V times t is equal to d. So velocity times time is equal to distance. Yay. Now, I didn't get t by itself, but I put it in a position where we can get it by itself. Why? Because right now v is being multiplied by t. So we do whatever the opposite that's being done to t right now, and it's being multiplied. So the opposite will be to divide it by v, and that'll cancel it out. Yay! But anything you do inside, you got to do the other. There we go. Okay, we get t all by itself. It's equal to d divided by v. Okay, so important. And then finally, c equals 2 pi r. Does anybody know what this is the equation for? It's for circumference. For circumference around the circle, which is just the different distance around the circle. So here we're going to solve for r. So what's being done to r? It's being multiplied by 2 and by pi. Did you know I can just divide by both of those at one time? I can just go ahead, divide by 2 pi, because that's just a number. So I'm just going to divide by both of them. And then look at that. Those cancel out. But anything I do to one side, got to do the other, right? Okay, there we go. It looks like r is kind of by itself now, and that's exactly what it wanted. So we had that r is equal to c divided by 2 pi. Yay, we're done. Okay, that is a skill I really need you to work on. Like work on. You do have a bunch of examples and a bunch of problems to work on in the physics booklet that we're giving you. So please work on those. And so just so you know, if you think that this is difficult, just keep in mind that this is, if you take Physics 20 with me next year, well, maybe with me, hopefully with me, although our other physics teacher is amazing. But if you make it there, we're going to be rearranging stuff like that. So what if you had to rearrange for A there? Yeah, that's fun. Doesn't this look like fun? Well, that is just something that is waiting for you next year. I know, you're so excited. So it's just unit conversions. I need you to be able to do that, okay? And you have done this in math, and you've done it in many years before. So I think for the most part, you're going to be fine, okay? So a few things that I want to know. Can you convert kilometers to meters? So you should know that 1,000 meters is equal to 1 kilometer. That is just, it's something you got to know, you guys. Minutes to hours. Well, what do you need to know? You need to know that there's 60 minutes in 1 hour, right? So if I have 120 minutes, that's 2 hours. If I have 90 minutes, that's 1.5 hours. It's an hour and a half, right? What about seconds to hours? Well, there's 60 seconds in 1 minute. And then there's 60 minutes in 1 hour. So guess how we get seconds to hours? Well, here's another way that I like to do it. I really like to do this factor label method. You probably learned it in math class. All right, so I know for every 60 seconds, I have 1 minute, right? And then I also know that for every 60 minutes, I have 1 hour. And so what we do with those two conversions, when we have two kind of conversions that are going from one to one and one to the other, really, really important here, just notice that the minutes and the minutes are on the top and bottom. That's giving me the conversion from seconds to hours. And so what that actually gives me is 3,600 seconds for every 1 hour. Okay, so that's a really important one to know, 3,600. Keep that in mind, but just remember it's 60 times 60 is all it is. So for example, if I want to convert 32 meters per second to kilometers per hour, well, here's how I do it. I have 32, and that's meters per second. So I really like drawing things in these nice fractions here. Okay, so first I want to convert meters to kilometers. Don't try to do both at the same time. So I know that I want kilometers and I want to get rid of meters. So therefore I'm going to put meters on the bottom of the fraction, kilometers on the top. Why? Because that means the meters are going to cancel out. And we'll be left with kilometers, which is really, really good. So we need the meters on opposite sides of the fraction. So what do I know? With meters and kilometers, I know for every 1 kilometer, I have 1,000 meters. Okay, so I converted the meters to kilometers. So I'm going to go 32 divided by 1,000. And that'll get me 0.032. That's kilometers per second. I don't want that. So now I need to convert the seconds to hours. Okay, so again, I know I want to get rid of seconds. Here they're on the bottom of the fraction, so I got to put them on the top. And I got to put hours on the bottom because I want hours on the bottom of the fraction. And there we go. My seconds cancel out. What do I know about hours and seconds? I know for every 1 hour, we got 3,600 seconds. So I'm saying take 0.032 and multiply it by 3,600. And I gotta type that into my calculator. So that is 115.2. And look at that, we got kilometers per hour. Oh, but one thing here, 32 is only 2 significant digits. I need to put my answer in 2 significant digits. So I need to use scientific notation, and it gets me 1.2 times 10 to the 2 kilometers per hour. There we go. Okay. Again, you guys just want to pause it for a sec. Can you try converting 100 kilometers per hour to meters per second? Give it a try. I'll put the answer up in a minute. I promise. Just pause and give it a try. All right, so surprise, surprise, to go from meters per second to kilometers per hour, we divided by 1,000 and then multiplied it by 3,600. And here, when we're going the opposite direction, we just do the opposite. We times by 1,000 and divide by 3,600. So 100 times 1,000, and then we divide by 3,600. And that is 27.7 continuing. Okay, which we can round up to 27.8 meters per second. And that is 3 significant digits, just like our question was, which is perfect. Okay, there we go. That's how we do that. Okay, so you can give this one a try if you are still here. But, and I'll just put up the answer, okay? But I hope you guys, yeah, got that. Go do a little bit of practicing, and I'll talk to you later.